Welcome to the third section of Lean Design, ENTR 3330. Welcome back. You're probably wondering why I'm opening with this poster, the headline, "We Need You." One of the things you're going to find in this class is some challenges in acquiring resources, more specifically on the technical side. So I have a suggestion for you. It's an open suggestion. Feel free to do it. You do have a budget. You have $300 to build your prototype. Many of you are going to require engineering resources. There is absolutely no harm in putting up posters or circulating flyers offering $20 an hour for engineering help. For a couple hours, you can get a really good design from an engineer. These are pretty simple projects. So I just put this poster together. I've had students in some of my earlier classes put the poster up and actually secured help. Somebody might work for them for 5 hours and put together a really nice project for them, or at least get them started on a project and give them some direction, or act as a coach for them. It's quick money for folks that are interested in helping, and it's a great way to recruit people to help you on your project. You do this for engineers, but you could also do it for creatives, or if you're looking for copy people. So think about it. You might want to put a poster up. Today we're going to talk about process and concepts. This is kind of in the project management space. We'll also talk about an example of good products that sell well, how to develop good product specifications and briefs, and creating some templates for collecting your market data. Class 4, next class, you'll be presenting your idea. It must be a physical product. You'll have 4 slides. You'll have about 10 minutes to present. The entire team should be at the front of the room. It's up to you how you handle the presentation. Some people are uncomfortable with presenting. I'd love to have the folks that are uncomfortable presenting present, and maybe the other folks as backup, but that's totally up to you. You have 4 slides. The first one's a problem statement. Second's a proposed solution. Third is alternative solutions today, the competitive set. And fourth is to state who on the team will be doing what, roles and responsibilities of the people on the team. 4 slides, 10 minutes. You can bring props if you like. If you want to bring an example of the problem you're trying to solve, or alternative solutions, totally up to you. You have 10 minutes to do a presentation. I'd ask again if you can bring it on a USB stick rather than downloading it from the cloud. It just makes the presentations go quicker. That would be helpful to us. And secondly, please make sure you bring a hard copy stapled with your name on it to hand in at the end of class. So when we talk about the product development process, there's really 5 steps to it. There's the strategy, ideation, they kind of go hand in hand. Concept feasibility, can you actually build it? Then the tactical exercise of building it and testing it, or piloting it, and then rolling it out. If you remember, I talked about starting with a sketch, going to design, and then today we can go right to prototype, this is a major change in product development over the last dozen or so years. It's what we call agile product development. No longer do we have to wait months to design and produce a prototype. We can do it very quickly. And why is that important? Well, it gives you an opportunity to do multiple iterations in a very short time frame. You can come up with a design, build a prototype, do some basic testing, some basic research on it, and then quickly pivot or adjust the product on the fly. Still fits within the 5-step product development process. You're still doing your strategy and your ideation, feasibility. The pilot piece is accelerated now because in particular 3D printing, and then final stages of rollout. Every project has 3 key objectives: time to market, quality performance, and the lowest possible cost. Time to market, quality performance, and lowest possible cost. Project management tools can help us manage all three of these objectives. This is the reason we try to put processes in to avoid delays, to avoid deviations and drifting. Kind of keeps you on target. A little bit more work to have a process, to have project management, but it's the most effective use of your time to accomplish the three prongs. Again, time to market, quality performance, and the lowest possible cost. The web has really flattened the world for us. It's allowed us to share information quickly. It's much easier to identify resources for communication. What used to take us several years to do to develop a product, now we can do in we average about 9 to 12 months to develop a new product from scratch. So the whole internet communications and web-based tools, 3D printing and CAD has just really accelerated exponentially the process of developing products and bringing them to market. In the past, back in the 1990s, everything was fairly linear. It was a serial process where one step led to the next step, which led to the next step. Today, in the last half dozen years, things have we've developed this parallel model. We can do multiple things at a single time, and by having the ability to have multiple processes happening at the same time, allows us to accelerate schedules and compress costs. We can do things quicker and more efficiently. That's a major change over the historical product development process, which was again linear. Today we're doing things parallel, and because of the digital evolution, the internet, the ability to have access to fairly unlimited resources quickly, has just compressed the whole go-to-market time and the product development process. Coupa in 2001 stated that there are two fundamentals for success in new product development. One is doing the project right, making sure that you have the right teams, that you do the right planning, you have the right control. But the second fundamental from Coupa is making sure that you do the right projects. You could have a great process, but be selecting the wrong products, and regardless of what your process you have, if you're focused on the wrong products, you're doomed to fail. And the inverse is true as well. You could select the right products, and without process, could take forever, could be too expensive, could develop the wrong product. So you need both the right project, and you need to do the project right. This is a traditional serial stage gate model where again everything was linear. Do this, when this is completed, do that, when that's completed, do that. Very linear model. Takes a relatively long time to bring a product to market. Again, we could take several years to do an electronics product in the past, and now we look at a target of 9 to 12 months to go from concept to finished product. I use as an example a simple stapler. In class, I would have the staple gun to share with you, but a staple gun that's developed was developed a number of years ago, actually had 15 stage gates in its process, from the initial idea to field research, understanding the customer, to the product design, down to the final specifications and manufacturing. The process, the 15 stage gates, which amounted to several years, again for a simple stapler, had three basic phases. It was product planning, so that's your strategy and ideation, product design, and then final design and launch, so refinements and launch. Um, this particular staple, the brand was Paper Pro, was developed globally. So you had virtual teams. You had a core team in the U.S. The design team was based in Boston. The prototypes came out of Pennsylvania, where the core team actually sat. The industrial design was done remotely in Wisconsin, and it was manufactured in Shanghai. It's a pretty standard model today. In the past, the communications issues, we didn't have the internet, so there were telephone calls, there were time delays, we had to ship products back and forth. Today, we accelerate that process. The time barrier is kind of gone away. Remember, Shanghai is they're upside down to us, so they're 24 hours. 12 hours different. So if we're 9 o'clock in the morning, they're typically somewhere around 9 o'clock at night. If you had to make a phone call, it'd be really challenging. But where the internet's available, it's almost 24 hours a day that you can communicate. We can send digital files very quickly. They can, with 3D, we can print them very quickly. So it just compresses the whole process. But in the past, it was linear, and they were looking for a 100-sheet stapler. So they knew what the problem was. They needed a solid stapler that fit their brand personality, and so they wanted to develop this 100 sheets. So the definition of the product was clear. They did some basic competitive research. They went out and they looked at what was available to solve this problem. They then did some market segmentation, which is an incremental research, where they tried to figure out who's going to use the product, what the applications would be. So it's all kind of in the definition of the product. They did extensive market research on competitive products. They looked at everybody else that was in the market, and frankly, it's a fairly cluttered commodity space. They tried to figure out how they could differentiate themselves, what they could do better than anybody else. This particular product, the Model 3000, was going to be a premium stapler in a commodity category. They were looking to get around $30 for a product that you could find similar products in the $15 to $20 range. So they had to differentiate themselves. Their claim to fame on this product was that they could easily do 100 sheets with little effort, and it had a really crisp design. Then they had to start doing their research. This is the legal piece. They started looking at patents to make sure that they were clear on all their patents, and that they could actually file a patent and protect their intellectual property. So they filed a number of patents on both design patents and utility patents for functionality. And it was at that point, when they knew they were free and clear, they knew they could build a product, they knew there was a market, there was that they could find a clear point of differentiation. That was actually the first stage gate, a decision where they sat with the management and decided should they go forward. They made a proposal to go forward, and it was approved to go forward. But I just want to pause there for a second. That was 6 steps that took months. Big company, took months to achieve. You think in this class, we didn't do that in the first week and a half. So, and what we're doing in class is not unreasonable. It's pretty typical of what we do in industry today. But this particular stapler was a number of years ago. It was back in the early 2000s, and it was done by a large company. So it wasn't really agile development. So 6 steps, we got to our first stage gate. Then we start to get into the product development, and this is where we really define both the customer needs and the technical specifications of the product. We have to figure out how we're going to manufacture the product. This was part of a platform. So in this particular company, they leveraged existing designs. They used something called TRIZ analysis, and we'll talk about that later in the semester. But TRIZ was developed by a Russian engineer a number of years ago, back I think in the 50s, And TRIZ basically says, look at the history, look at what you've done in the past, and then pick out the best ideas from projects in the past and apply that to the project you're working on. That's it in a nutshell. It's a pretty interesting process. Again, we'll talk about it a little later in the semester. You're welcome to look it up. The fellow was a pretty interesting guy. He worked for the military, and he had a rigid format for doing analysis. But the reason I talk about here is, since this is a staple that's part of a family of products, using TRIZ, they could go back and look at TRIZ analysis. They could go back and look at some of the previous products and take the best elements and common elements in, rather than reinvent them, just leverage them in the design of the 3000. Designs and functions. But once they quantified the selection and chose the final project, that's what with. And now we had to get, in step 11, we actually get into the detailed product design. We have to figure out how it works, what the guts are, what the components are, how they're gonna be manufactured, where they're gonna be manufactured, how they're gonna fit together, who's gonna put them together. And the cool thing on this product, this is, again, back in the early 2000s. There was software available, not like today, but there was software available, so they could do a lot in SolidWorks and some CAD for the design. Today, a design like this, as sophisticated as it appears, could easily be replicated in a 3D lab. There's a number of programs that you can use to do basic designs, mechanical designs. You can also align yourself, obviously, with the engineers, as I mentioned earlier in this session. You find a good mechanical engineer, they can throw something like this together very quickly. So we're at step. Start to cost out the product. The financial comes into play. Start to look at the components that are required, the tooling that's required, the assembly costs that are required, and we do a cost build. Once you finish your cost build, you may end up at a cost that exceeds the value of the product, which, and then you have to go back and refine the product. You may have to pivot, you may have to change the design, you may have to change some of the components. In the case of the 3000, they actually changed some of the metals, the thickness in the metals and the type of metals, so that they could hit their cost targets. This is the second major stage gate, decision gate. They now know what the product looks like. They have the costs done. They know that it's that there is manufacturing feasibility. They have market research that says it fills the consumer needs. They go to management again, and the project's approved for manufacture. So this is about the stage in our class that we'll be at when we're done. You will be presenting to a panel, basically asking if they're interested, and you go on to manufacture. So this is the second major stage gate. In this particular project, this is about 2 years into the project, and then we get into the final product specifications and final design. Any tweaks that need to be made, both to the product and to the manufacturing, and then we go to tooling and production. Production started in the P1 samples, which is the first run of samples, were in 2007. So it was just about 2 years to develop this product, and it's just a basic stapler. So this is where the low cost of the rapid development comes into place. With these new digital tools, with 3D printing, we can do stuff really, really quick, both on the engineering side, but also on the design side. And we can do rapid prototypes. You can do a fairly complicated, fairly sophisticated prototype 24 hours, review it, make your modifications, and run it again, and have another one in 24 hours. You just condense the whole process. These might be a little bit dated, but we're talking about 3D printers. no need to worry. But you can get a really good 3D printer today, um, well under $5,000. Some home printers are now under $1,000. You can find any number of folks now providing components. So there are shops that actually produce sub-assemblies and components on demand. We don't need steel tooling anymore. We can just produce them on the fly using 3D modeling and etching and steel fabrication shops to do it. So you can do prototyping very, very quickly today. Here's just some links for software and prototyping. Quick about products that sell well. There are three types of opportunities in products, good products. There are improvements, extensions, or variants. That's when you're taking a product and you're just making it a little bit better. Typically fairly low risk. Since you know the first product was successful and you're going to make it better, there's not a lot of risk involved, and there's some pretty good upside. The second is adjacent growth, and that's where you look at a product and you say, hey, I can do some accessories, or I can do a product that complements the first product. It's a medium risk because you're not sure anybody needs the accessory or the adjacent product. And I think a lot of mobile phones and all of the accessories that have been developed to complement mobile phones, probably 99% of them fail. There just isn't the demand for them. They sound like a cool idea, but there's no real demand. There's no proven demand. So we would call those type products medium risk. And then new technology or new categories, disruptive technology, stuff that is like a major change, a major brand new innovation. Those are very high risk, capital intensive, high risk, certainly high rewards, but the most risky projects that you can work on. Improvements, extensions, variants, and cost reductions is a really safe place to be. A very low risk, typically not capital intensive, and usually sizable markets with good return. Low risk, typically on a per dollar amount, low returns. It does have the lowest barrier to entry because you're not inventing anything, but there's also low investment. So you're just making stuff work better. There's a pretty good chance you're going to make low margins, low profits, but on high volumes. In the medium risk product, the return, the reward is typically medium to low. It's kind of an uncertain place to be. You have to invest capital on developing products that you're not really sure anybody needs. There's no proven market for it. And then on the high risk products, you can have medium to high return. I mean, typically the higher the risk, the higher return. First movers or new technology, new IP that solves a real problem typically commands a higher price, generates a higher profit, and provides a better ROI for investors. Guys with the heliostat should have quit before they started. The mouse guys, when we failed the first time, shouldn't have continued to invest. The second thing is understand the pain point. The last comment here, how much you get it, how much you understand the pain point, and the ease with which you make people's lives better. The more effective you are in solving the pain points so people live a better life, the more successful you will be. If you were in class, you would see I would show you a product. I was a product manager in a large company for a number of years. I launched the very first VGA digital camera for the mass market. Um, it was back in 1998, and the product was wildly successful. We sold millions and millions and millions of them. I was a fairly young guy at the time. I was very successful. I used to like to walk around the hall, big smile on my face. I nailed it. I nailed it. I had a very successful product, and I was pretty proud of it. So, what does a successful product manager do when he's successful? First of all, you get the check and you go on vacation. You might buy a new car. Things good. Well, you want to get onto the next project. So, I had a successful VGA camera. Um, it was widely distributed. It was Walmart's best-selling product for years. It was back in the day. AOL used to sell products. It was their best-selling product. It was on Amazon. It was doing really well. But as a user, I said, "Hey, I got a digital camera. I have an MP3 player, which you guys probably don't remember, but we used to carry around MP3 players, and mobile phones were just being introduced. So I had 3 different devices I had to lug around. And that's on top of my laptop and whatever materials. I just had a bunch of stuff that I had to carry. So I had this bright idea. I said, "Hey, digital camera has a processor and it's got a PCB, a printed circuit board with a memory and a processor and storage. Why not just add an earpiece, a plug, a jack, put in a little bit of extra circuitry, and make that digital camera also an MP3 player? And that way, I would always have my music with me when I'm taking pictures, and I'd always have my camera with me when I'm listening to music, and I'm only carrying one device." I thought it was a brilliant idea. And so I convinced the company. We went through our stage gate process. We convinced the company to build this new product. It was a Polaroid Photomax MP3 digital camera, launched in 2002. The end of just the beginning of 2002, just as our product was shipping, Apple introduced the iPod with iTunes. My Polaroid Photomax MP3 camera is now available on eBay for $10. We never sold any of them. The Apple iPod is probably one of the most successful digital pieces of digital hardware in history. I was so totally focused on my success, I forgot to look around to see what was going on in the category, what other companies were doing. I didn't pay attention to Apple at the time. They weren't a big deal. I didn't really care about who else was working on MP3. All I knew is I had a successful digital camera, and I was going to launch a second product that included an MP3 player. I didn't pay attention to the category. Key lesson learned: you always have to look at the competition. You always have to be checking in to make sure that you're on top of it and that you're not missing a beat against the competition, and that you're meeting the needs of the customer. Make sure you solve a real problem. Make people's lives better. Make the world better. Always think different. Don't get stuck in the box. And when somebody says no, say yes. Listen to your customer. And this is a really important one. The best advice you get will come from your customer. And when you start ignoring what they say, you're destined to fail. You have to understand what they're saying. But there's a caveat. Don't expect the customer to tell you how to solve the problem. They have no idea. That's your job. But as you develop solutions for the problem, make sure you ask the customer if it works. The more research you do, the better the results. Again, and recognize all your competition. Pay attention to them. Check on them every day. There's no excuse not to know what they're doing. There's no excuse to launch a MP3 digital camera. And last, make sure the numbers work. Don't fudge. I absolutely hate this. Don't fudge the numbers. I hate I hate when people say to me, Steve, if I can only get 1% of the U.S. population, if I get 1% of the Chinese population, I will. You won't. You won't. You will never. What you need to do is do a bottom-up realistic build and say, okay, I know who the people are. I know the demographics. I know the psychographics. I know their spending habits. I know their buying habits. I know what their pain point is. And this is how many of those people exist. And this is why and how many I'm going to convert. Don't fudge the numbers. In the end, it'll destroy you. Just very quickly, I want to talk about creating product specifications and briefs. There's two types of specifications. One is the usability specification. That's how the customer will interact with it. They see human factors. The button's big or the button's small. Where are the buttons? How many buttons do you have? We're going to talk about TV remote controls and shortly. And there's just too many buttons. I don't need it. I want to turn the TV on and off. I want to turn the volume up or down. So there are the usability specifications. What's the problem being solved, and how many steps, how few steps will it take the user to accomplish the solution? Second specification is design and manufacturing specs. This is where you have to figure out what type of materials, the engineering involved, the mechanical and electrical designs, costs associated with building the product. You have to make sure you're covering any government regulations or ordinances. And are there any specific manufacturing related requirements? Does it have to be waterproof, or does it have to be a sterile environment? So you have to start thinking about how you're going to build this thing. What are the requirements? Are there any special needs when you build the product? Interface, usability, the manufacturing specifications. Again, you need to fill these out. These should be available for the design people and for the manufacturing people. Product brief. This is a document that's going to help you clearly define the problem that you're trying to solve, and then how you plan to solve it. This is putting your product into words. And then again, we went through this last week, but I just talk about it one more time. It's probably the most important document that you'll do. You need a single page that tells on the left side what the design problem is. On the right side, you provide a brief. The left side is the issue that needs to be solved, and then on the right side it's how you're going to solve it, and then the specifications related with it. Any questions or comments? Market data. We talked about this earlier.